All right. Well, what an inspiring afternoon of potential new treatments and advancing human health, which is just so important for all of us. So I'm really looking forward to add to that. Um, I I want to start by talking a little bit about Stingray and what we're trying to do. And the difference here is we are not directly trying to kill cancer. We are trying to stimulate the immune system to kill cancer. And there's quite a few advantages to that because your immune system is designed to do that. But unfortunately, just like infection, you get attacked maybe 500 to 1,000 times a day. Your immune system fights it all off, but every once in a while something gets through. And cancer is the same way. So we want to stimulate and energize innate immunity, which is the missing component in today's therapeutics for immune oncology. Everything we have in immune oncology is an adaptive immunity, the other arm of the immune system. But cancer can shut off both arms. So we need to energize innate immunity as well so we can bring new solutions to terrible diseases. Next slide, please. Just three areas I want to concentrate on of truly enormous medical need. First of all, the first cancer that we're going in, and we should start this trial Q2 of this year, so in a few months, is a disease called microsatellite stable colorectal cancer. And what MSS really means is just that the cancer is able to repair its own DNA. Now, this is a terrible attribute for cancer to have because a lot of our therapeutics are DNA damaging agents. And fundamentally, the cancer just laughs at them. So in this disease, 153,000 cases a year and 53,000 deaths a year just in the US, only a 13% 5-year survival. That means 87% of people that get this disease, get all the treatments we have to throw at it, are gone before 5 years is up. And this is really why we all get colonoscopies, and I certainly encourage you all to continue to get them. Now, there are two other diseases that are not cancer, but where innate immunity is really important. One is hepatitis B. And hepatitis B is a virus that we can't cure. It has infected over 300 million people on the planet and about 800,000 deaths a year. We do have hepatitis B antivirals, but you can think of them a little bit like you think of HIV. We can't cure the disease. We can suppress it. That's all we can do. We think that adding a host immune defense drug like our drug might allow a cure for hepatitis B. And then finally, this bacteria, mycobacteria, the only bacteria that actually exists inside our cells. And the way it does it is it exists in our cells because it dampens our innate immunity. So if we can stimulate innate immunity, we might be able to cure it faster. There are two arms to it, avium and tuberculosis, and they're both very significant. Next slide, please. So what are the funding possibilities for these kinds of endeavors? Well, first, for MSS-CRC, we have been funded to date with angel high net worth individuals. Venture is possible, but after clinical data, venture philanthropy, and then mission funding and hospital conversion foundation funding are other areas of funding that might be possible because this is a big disease and it will make a good deal of money. But then hepatitis B, not so much, primarily because this is mostly a disease in Asia, so it's not as interesting. And then finally, mycobacterium, particularly tuberculosis. Now TB does qualify for the Tropical Disease Priority Review Voucher, which is worth about $100 million if you get to file your NDA and get it approved and get to market. You can get this voucher, and it has about $100 million value. But TB is extremely uninteresting to venture. And Mycobacterium avium is a hospital-acquired disease, and it's also pretty uninteresting to venture. So anything we could do here really needs mission funding, impact investing, grants and awards, or hospital conversion foundation. It needs some help. This is not something we can do with the normal economic model. Next slide, please. So this is the team. This team has over 200 years of pharma plus biotech experience. I myself worked for Eli Lilly for 28 years. I launched 5 drugs for Lilly. This is the 4th biotech I've been CEO of. Dr. Sunil Sharma, who's my partner, is an eminent clinical research oncologist. He's been PI on over 150 phase 1, phase 2 clinical oncology trials. Monil Shah, who directs our clinical operations and is our chief development officer, has been in immune oncology for 15 years. And across the board, the rest of the team equally as strong. Next slide, please. So how do we solve these problems? And the goal is to add innate immune response to therapy. So in cancer, our drug SR-8541A, the idea is to add that to checkpoint inhibitors in what oncologists call cold tumors. Cold tumors is just a shorthand to say that innate immunity is turned off. In hepatitis B virus, we want to add our drug to HBV antivirals to try for a cure instead of just suppression. And in tuberculosis, we have a platform which actually works both against the molecule that tuberculosis makes to suppress innate immunity and works against the human version. And this program has a real opportunity to make a difference in tuberculosis and Mycobacterium avium. Next slide, please. So one of the problems with family office investing is in biotech is how do you know that this is a great company to invest in? How do you know that the company has been well vetted? And so one thing I can say to you is that at Stingray, we actually have received 16 million in scientific awards, 14 million from the Cancer Prevention and Research Institute of Texas, which covers us for the next 3 years, and 2/3 of our CRC trial plus 2/3 of our staff costs. And we have to come up with the other third. And then we have a $2 million National Cancer Institute award that we're in the second year of and receiving the second million of. By the way, our equity raise has been $9 million to date. So we're almost running $2 of award and grant funding for every dollar of equity. Next slide, please.
Yeah, how much non-dilutive capital?
16 million.
So 16 million non-dilutive, 9 million if dilutive.
Right. So next slide. I think that's an unusual company that can do that.
That's a pretty good number.
So
what was the last after money?
the 22 million is the post money after our last round.
Pretty good after 16 million.
Yeah. So we also have validation from impact investors. So we have family offices that have joined our program that we're very proud of. The GKCC family office that will speak to you a little bit after my speech. Dean Krause will talk a little bit. Spring Hood Ventures out of Boston. It's a great investor, really great impact investor that's been in the company. And Catalyst Impact Foundation, also out of Boston, which is really interested in accelerating breakthroughs and has invested in us. So we're very pleased to have this validation as well. Next slide, please. Now, just a little bit, and this is as sciencey a slide as I'll give you. And it may be too much, I apologize. But this is the innate immune system and how it works, and it just gives you a little sense of what we do. So the way it works, we're looking here in beige at a tumor cell, and in blue, a white blood cell. We call it an antigen-presenting cell. And what happens is that innate immunity starts in every cell in our body. That's why we call it innate. And it's looking for foreign DNA, which every virus, bacteria, parasite, and eventually cancer has. And when it sees it, it keys this molecule C gas. This molecule C gas is the first messenger. It makes the second messenger, which is 2,3-cGAMP. 2,3-cGAMP then goes through the STING pathway. It's what we named our company for. STING stands for stimulators of interferon genes, and it creates interferon locally. And interferon is your first fighter to the scene, and it does many important things. It inflames the area, which brings white blood cells to join the fight and adaptive immunity to join the fight. It also fights, it also keys natural killer cells to join the fight. And so a lot of things go on. But what happens is cancers are very smart, and as they become aggressive, they build up ENPP1, and ENPP1 degrades cGAMP. And cGAMP does not create interferon. Instead, it's captured by CD73 and adenosine is made. So what happens is the pathway is perverted to make adenosine instead of interferon. And adenosine is very pro-metastatic and broadly immunosuppressive. So the pathway fires, it sees the cancer, it's trying to make interferon, it just supports the cancer through this perversion by making adenosine. So what we do is we block ENPP1 from being active, so that restores the pathway, interferon is made, white blood cells come, and the immune system works like it should. Next slide. Okay, yeah. I'm trying to finish in 4 or 5. Okay, well, I just want to talk about why we're here today. We have been well vetted by experts, impact investors, CPRIT, NCI, Regional Venture. Many individual MDs and PhDs have invested in the program. My bet is that you know someone impacted by these diseases. And as Norm said a little earlier today, disease doesn't care about your FICO score. Our PRO's solution isn't a luxury. It's a life necessity for people who are afflicted. And anyone can be afflicted. I think this family office group that Marty has built over time, this represents some of the most thoughtful and capable people on the planet. And I hope you'll consider being part of the solution. Next slide. So I'm going to give you a quick round on each of these diseases. I talked about a little before. In MSS-CRC, colorectal cancer, the best thing in development has moved the needle from 13% to 23%, but only if you don't have liver metastases. If you have liver metastases, it doesn't work. Well, what's the problem? Well, 85% of colorectal is microsatellite stable, and the vast majority of macrosatellite stable comes with liver mets. So this still really doesn't get us. But if we add our drug, we think we can make a huge difference here and maybe get the standard of care up substantially. So that's what we're trying to do. I hope you'll join us to try and conquer this deadly disease. Next slide. In HBV, this is a huge disease. There is a great vaccination, and if everybody got vaccinated, that'd be fantastic. But in fact, only 25% of people get vaccinated. And once you get this disease, it's very difficult. An important note is there's almost universal transmission from mother to child with this disease if the mother has it. So that's very, very bad. And we maybe could conquer this deadly disease with your help. Next slide. You know, MAC and TB are very terrible diseases, and greater cures might be possible. And this is really an area where economics can't justify the effort, but mission funding could and really make a difference. And the thing about TB is it's easily spreadable. So even though you might not be one of the high-risk populations, you can run into somebody with TB and have it the next day. Next slide. I just want to say we have very strong IP. We don't own anybody anything. We did all our own biology and chemistry, no university royalties or anything else to siphon off economics. Next slide. This just shows the timeline. We're looking really at the next 3 years and trying to make the most out of that. We think we can get through phase 2 with CRC, and the others we'd like to get to IND filing. Next slide.
Are you in the line for more grants?
We're always trying for more grants. Absolutely, Marty. Can you get me a next slide, Alexis? Yeah, okay. Just quickly, the competition, we're the best in class program, and I'd be happy to run through these with the other companies that are out there. Next slide. And then finally, this is my last slide. You know, our colorectal cancer program is close to license and capital efficient. We plan to license it to big pharma, and that should be a great exit for us in 2026. There's tremendous need for new therapies, big potential in cancer, company with tremendous grants and awards received, lots of notable investors in the program. This is a major impact drug with a team that's doing it again and a leading program. If you're interested, we'll have a follow-up webinar on Monday, January 26th at 1 p.m. PT. And thank you very much for listening.
Any questions here or any other?
Why so long to get it into patients? It's taking so long.
Well, we have to prove it in patients. So it's the clinical trials that take so long. And so in the CRC program, we are in the clinic now. We will start with the combination trial for CRC that we hope will really give what we need. We're going to treat 72 patients, and it'll take to 2026 to get that done.
What's the size of the current financing round?
So we're looking to raise 10 million, a Series A, and that would complement the money that we have from CPRIT. And then we would hope from an impact investing or mission investing for 7.5 million for HBV and 5 million for tuberculosis and MAC.
Is a Series A, is that a price round?
Yeah, we've priced it at $5 a share, which is a pre-money of 29.3 million, which takes
3 million after 16 million of grants.
22 million post-money plus another 14 million of new grants. So we felt take half of that, and that should give us an affordable pre-money. I think I've got John and Dean on. Okay, I would love if.
Hi, John.
You want to introduce them?
Yeah. So Dean Krause is a family office. He's an advisor and board member of the family office and an investor in Stingray. And I just thought it would be great to hear from another family office.
Hi, everyone. Thanks, John. I'll keep it quite brief, but we, like John alluded to, we invested in Stingray. And at GKCC, we're impact investors and a philanthropic family office solely committed to investing in oncology. And we're really, truly excited about Stingray in our investment and also continuing to support, expedite the technology and see the science be pushed along into the clinic. And I think the thing I would add is, you know, with VCs, because in all the companies we invest in, we see angels, we see VCs, but there's a lot of, and they're great, but there's a lot of groupthink in terms of concepts to invest in, and also staying specific to a certain modality. So what we try to do specifically is look for very novel, unique ideas like Stingray that we're very interested in. This specifically, it's the abscopal effect and how immunotherapy could prove this proof of concept idea. And so I think that there's an incredibly important role specifically for Stingray, where if they could prove this platform out, it creates a lot of value for you know, patients. It could be potentially a new standard of care, and then also kind of change the landscape for how immunotherapy is viewed. You know, talking about this abscopal effect. So we're super
Thank you,
excited.
Dean. Thank you, Dean. Really appreciate it. Okay, thank you, Marty.
Jonathan, thank you so much. Appreciate it.